Okay guys, so in this video, we are going to take a look at how to write an equation of a quadratic function in vertex form. We know that vertex form from our formula chart is this: f of x equals to a times x minus h squared plus k. This is from our formula chart. So in order to write an equation in this form, we are going to need the y value, the x value, the h value, and the k value. And all of those can be found on your graph. In order to write a vertex form, you're going to want to have a vertex. And you're going to want to have a point on the graph, because that's what's going to give you your h comma k, and that's what's going to give you your x comma y. Okay, let's take a look at our graph. Here's my graph. I know that my vertex is right here because it's the lowest point of the graph, and it's at 4, negative 5. And I know that my point is right here at 7, 1. Okay, so I have a vertex, I have a point. That means I'm going to use this equation. Y equals to a times x minus h squared plus k. And if I'm listing out my vertex and my point, my vertex is going to be 4, negative 5. That means that my h is equals to 4, my k is equals to negative 5. And then I have a point, and the point is 7, 1. That means my x is going to be 7, my y is going to be 1. We're going to use this. We're going to use this and plug it into the y, x, h, and k of my formula. So here we go. Y is 1 equals to, I don't know what my a is, so that's something that I need to solve for, times x is 7 minus h is 4 square plus k is negative 5. So it's really minus 5. Now that I have that set up, notice that I have all the variable y, x, h, k filled in with a number. So the only thing I need to do right now is solve for a. I need to figure out what that a is equals to. To do that, I need to combine any like terms that I have. So 7 minus 4 within the parentheses. That's going to give me 1 equals to a times 7 minus 4 is going to give me 3 squared minus 5. We know that we can work out 3 squared. 3 squared is going to give me 9. So I have 1 equals to a times 9 minus 5. Alright, now I have an equation. 1 equals a times 9, or 9a minus 5. I have to undo it to get a by itself. To undo, the first thing I undo would be minus 5. So I'm going to add 5 to both sides. That's going to give me 6 is equals to a times 9. And if I need to solve for a, I need to divide it by 9 on both sides. So that's going to give me a equals to 6 over 9. Simplifying that, a is equals to 2 over 3. Okay, so now I know what my a is. A is 2 over 3. So when I go back to my formula, I'm not going to need to use the 0.7, 1 for x and y anymore. Because in order for it to be the graph, this graph has multiple points, not just 7, 1. So my x and y are now back to x and y, and fill in the rest. So I'm going to get y equals, my a is 2/3, so I plug that in, 2/3 times x minus, my h is 4, plugging that in, square, k is negative 5, so minus 5. The reason why I still plug in 4 comma negative 5 for my vertex in the equation is because there's only one vertex. That 4 comma negative 5 will never change. Vertex will never change. So my final equation is y equals 2/3 times the quantity of x minus 4 squared minus 5. That equation describes my graph. Now, why don't you go to page 16 on your note packet and practice writing an equation using the vertex form for the two graphs on that page.